Assalamu alaikum. So, in our last class, we were discussing about transistors, right? There we discussed the characteristic, the input character, output character, and the transfer characteristic graphs. So today we will be discussing about biasing of a transistor. So the topic is biasing of a transistor. Biasing of a transistor. So let's say we have NPN transistor. We have an NPN transistor. And it is in the common emitter mode. So this is going to be our collector and this is our base. Here we have the emitter. So let's give, we are connecting this to a voltage source, okay? So VCC. Let's say this is VB and VC. So now we are going to apply a voltage. We are going to apply a signal of plus 0.005 plus 0.05 and minus 0.05. So this is the voltage versus time signal. So this is a very small signal. We know if we apply this signal to this input, if we apply the signal to VB, what can you tell about the IB current? For this VB, for the above VB, IB current is going to be 0, right? Because at least we should have 0.7 voltage of supply. Then only there will be an IB current and therefore an IC current, and we will get a voltage at VC. Okay, so here so let's consider a small voltage. Consider the above small voltage is applied to the base of the transistor. So for this small voltage, we know that IB current is going to be 0. For the above voltage, IB is equal to 0. Okay, IB is equal to 0. And therefore, IC is also equal to 0. Therefore, IC is also 0. Hence, there is no amplification. There is no amplification. Okay, do you get the idea? If IB is equal to 0 only, because IB is equal to 0, IC is equal to 0. Although we apply a signal, we won't get that signal over here. Instead, we would only have a flat line. Although here we have a varying signal. Okay. Therefore, we are not able to use or we are not able to amplify this signal. To overcome this problem, we do something called biasing. Biasing means we already keep this point at 0.7 voltage. We place it at 0.7 voltage. Therefore, if I give a signal, it will change that voltage. For example, we can do this. we can, this is my transistor. So from this supply, we are giving a small voltage to VB. So this is connected to plus VCC, and this is connected to VC, and this is earth. Now, by using a resistor RB, base resistor, we already placed this base voltage at 0.7 volts. So, this is already biased. This is already sending current. Okay, it allows current through it. Already IB current is not zero because this is 0.7. Now, when I apply a signal, the same signal that we applied previously. So this is plus 0.05, plus 0.05, and this is minus 0.05. So if we apply this signal to this point, if I apply the signal to this point, now what will happen to the voltage? The voltage will go to 0.0. When this signal is over here, the voltage becomes 0.0, sorry, 0.75. 0.75. When this voltage is over here, it is 0.65. You might think that when the voltage is at 0.7, only current will flow, but slightly below 0.7 also there will be a current flow because we had a knee voltage, right? Knee voltage only we considered as 0.7. Okay. So here also we have a current flow. Okay. So here, mm, now, 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 if the base, now here, so here below this write down, if the base voltage, or if the base is kept at a potential, of plus 0.7, plus 0.7 volts, using an external source, and now the signal is applied, and output is observed, Is the idea clear about biasing? Why we need to bias, and we will discuss what are the other possible ways to bias. For now, did you get the idea why we need to bias? What is the purpose? Okay, so next topic, types of biasing. Types of biasing. So in biasing, we have mainly two types. There might be several types, but here we are only discussing about two types. First one is the base resistor biasing. We can use now this is a transistor. To get a portion of the voltage supply from the VCC, I can use this resistor, and we call this resistor as the base resistor. This is the collector resistor. So here this is one mode of biasing. Okay, this is base resistor biasing. Base resistor biasing. And then we have another method. Instead of using a single resistor, now we are using a potential divider. Now we are using a potential divider. We don't need this. So this is, let's say, RB, this is R dash, RC, and RE. So here, this is a potential divider. So we call this type of biasing as the potential divider biasing. Potential divider biasing. I will copy so far. Okay, let's try a few examples related how to deal questions with these transistors. So example one, say our supply is 10 voltage and this resistor is 1 kilo ohm. RC resistor is 1 kilo ohm and our RB resistor is 100 kilo ohm, and my supply is uh, instead of giving a sine or AC signal, I'm giving a DC signal plus 5 voltage. When we have plus 5 voltage, let's say beta is 100, beta is 100. Here VBE is 0.7. Okay, VBE 0.7. Now we have to find, our aim is to find IB, IC, and VCE. Okay, we are trying to find IB, first one IB, second IC, third VCE. Okay, now here, uh, when this transistor is forward biased, VBE is 0.7. What does this 0.7 mean? 0.7 means from your emitter, base over here, this point is zero point 0.7 voltage greater. So our emitter is 0 volts. Therefore, this point has to be 0.7 volt. Okay, similar to what we did in electricity. So this point is 0.7 volt. My first thing is to find, my first question is to find what is the IB current. So the current through this resistor is the IB current. Now we can find the IB current because we know the potential difference across it. To find the IB current, I know the potential difference. Potential difference is 5 minus 0.7 is equal 100 into 10 to the power 3 into I. So if we simplify this, we get 4.3. 4.3 into 10 to the negative minus 5 is equal to I. So I is equal 43 microamperes. Okay, I is equal to 43 IB. IB is equal to 43 microamperes. Second, we have to find the IC current. If you want to find the IC current, we can use here it's in active mode. That is important. It is in active mode. Since in active mode, for active mode, we know that we have a relationship for IC and IB. That is IC is equal beta times IB. So IC is equal 100 times of IB, 43 microamperes. So IC is equal 43 into 10 to the negative 4. Or otherwise, IC is equal 4.3 milliamperes. Now we have to find what is VCE. To find VCE, we know that VCE is VC minus VE. How can we find VC? What is VC? This point over here. This voltage is VC. But I know my IC current. Okay. So here VC is equal to VC minus 0 because E is 0. Therefore, this is equal to VC. How to find VC? Here, this voltage over here is VC. Okay. But I know that 10 minus VC is equal IC into RC. So 10 minus VC is equal, what is IC? That is 4.3 milliampere. 4.3 into 10 to the power minus 3. RC is 1 kilo ohm, therefore 10 to the power 3. Then we have VC is equal 10 minus 4.3, therefore this is equal to 5.7. Got the idea? So it's if you know the equation, it's similar to electricity. Okay, I will copy it. Don't need time. Aja, how about you? Okay, I'll give one more example. Give it a try. Example 2. 2.2 kilo ohm, and this is 240 kilo ohm, and VBE is equal to 0.07, and beta is 50. This point is Earth. You have to find, this is again in active region, active mode, find IB, IC, and VCE. Can we give it a try? Take, sorry, here we get, yeah, when we simplify, we get 47 microampere from here on continue. So here it is in active mode, active mode. Therefore, we can write IC is equal beta times IB So IC is equal 50 into IB, that is 47 microamperes. So if we multiply, we get 2.35 milliamperes. So we know this current, and we also know this voltage as 12. Now we have to find what is VC. So third one, 12 minus VC is equal 2.35 milliampere into 2.2 kilo ohm. So if we multiply, we get 2.35 into 2.2, that's 5.17. So VC is equal 12 minus 5.17 VCE. No, we are finding VC. So VC is equal 6.83 voltage, 6.83 volts. So we have to find VCE, but VC is equal to VC. Therefore, VCE is equal to 6.83 volts, since VE is equal to 0. Okay, here is this answer. Copied, noted, right? Let's try one more question. Example 3. 4 kilo ohm, 4 ohm, and this time we also have an RE resistor, 10 ohm. Beta is 100, and the supply voltage is 10. Supply voltage is 10, and this is earth. VBE given VBE is equal to 0.7 volt. VBE is 0.7 volt, comma, active mode. Okay. Now we have to find IB, comma, IC, and VCE. But this time we have a resistor over here. Therefore, VE is not 0. VE is not 0. It will have certain voltage V. And this will be over here, the voltage will be V plus 0.7. Is the reason clear? Why it is not 0 this time? Because we have a resistor. And this is 10 volts. So to find IB, IC, and IE, we cannot straight away uh, use the, we cannot straight away find IB, IC, and VCE. Okay, we will have to find them simultaneously. We only can find them simultaneously. So here, The difference between these two will be VCE. And I'll write the three equations. I'll write the three equations that we will need. We have three unknowns, therefore we need three equations. Now just consider this line from here to here. We have a potential drop of 10. Therefore, 10 is equal. Here I will have IC current. So for IC plus, here we have a drop of VCE. VCE plus, here current will flow down and that is IE. Therefore, that is 10 IE. But we know that IE is equal IB plus IC, right? Here, this is IE is almost equal to IC. Okay, therefore, using this, we will rewrite the first equation. 10 is equal 14 IC plus VCE. Is that clear how I got this equation? We can make assumptions, okay? We have assumed that these two are almost equal. So that's the interesting part about this electronic section. By taking a small assumption that these two are equal, we can easily simplify. And we can get another equation between IB and IC. I can go through this path also, right? If I start from here, if I go through this path, if I go through this path, also the potential drop is 10. So 10 is equal. In this path, we have IB current, 4000 IB, 4000 IB. Here the drop is VBE. So that is 0.7 plus VBE plus again here we have 10 IE. But we can write this as 10 is equal 4000 IB plus 0.7 plus 10 IC. But we know that IC is equal beta times IB. Therefore, IB is equal IC over 100. Okay, so let's put it over here. Then we get, if I take this to the other side, that's 9.3. 9.3 is equal, in place of IB, I can put IC. Therefore, I get 4000 into IC over 100 plus 10 IC. Therefore, we get, after simplifying, this is 40, together it's 50. So 50 IC is equal 9.3. So IC is equal 1.86 milliampere. Am I right? 9.3 over 50. This is equal 18.6 over 100. 1000 means divided by 1000. That means 186. 186 milliamperes. 186 or 1.86. Hundred 186, right? Yeah, 186 milliamperes. So now we have found IC. From there we can find IB. Therefore IB is equal 1.86 0.86 milliamperes. And now we can find what is VCE from the first equation. From the first equation, 10 plus, sorry, VCE is equal 10 minus 14 into 186 into 10 to the minus 3. So if we simplify, we get VCE is equal 10 minus 2.6. So VCE is equal 7.4. So is it clear why we had to go for simultaneous here? Because this time VE is not equal to 0. Okay, it is some other value. Both of you clear? Have you noted? In a minute, the meeting will end. Noted, Sarah and Saja.